please do say something. Okay, so this worked really, really good in my other class. Let's see how this works for you guys. We're not off to a good start, GeoGebra. Yeah. Okay, if you guys would, please check out the screen. And you have only one job right here. That's just observe and make some observations, make some connections, all that good stuff. This goes 0 to 4. Hello. Whoops. Okay, guys, if I could get your full attention, I know there's the temptation to just check out when there's some technology stuff going on. Please don't. So can you all see the yellow region right there? No, thank you. Can you all see the yellow region now? Check it out. So you see how the yellow region is being created by a square root function and also by a line? Yes?
Yes.
Okay. So in just a second, what I'm going to do is I'm going to revolve that around the x-axis. And I want you to think for a second. I want you to try to visualize and think what this will look like what kind of shape it will be. It's like, I'm asking you just to do this totally in your head. We'll do this over there by Zach. And I have one really crucial question for you. If I did revolve this region around the x-axis, would the resulting solid be genuinely a solid, or would it be more like a bowl or have a hole? I don't know if it would have a hole or not, because doesn't the yellow region hit the origin? It'd be like a really odd-shaped bowl. Okay. The inner surface of the bowl should be linear, and the outer surface should be curved. So check this out. I'll do the revolution here, and we'll see if those things that we're thinking show up very well on the screen. So if I revolve that region, can you see the bowl-like shape showing up? But it's hollow, right? Oh, I didn't want it to do that. Go back here. There we go. It's hollow in there. Can you see how the x-axis goes into there? But you see how there's no hole? Like this thing, you could put like ice cream or cereal or something or soup in there. Like if you oriented it the right way, it literally is a bowl. If I took, you see where it says up there n equals 33? You see it? That's the number of the number of little rectangles that I'm using to generate this shape. If I took the number of rectangles and I decreased them from 33 down to 7, do you see how the shapes that are generated could be called washers? Like, and I'm not talking about a washing machine, I'm talking about like a hardware store washer, the thing that goes between the nut and the bolt. You see it? Okay. There's all kinds of other things we can do with it. So check this out. If I took the exact same region, I'll unrevolve this. So we're back to the same region. What if instead of revolving around the x-axis, what if I decided to change things up a little bit and I revolved around the horizontal line x equals, how about -4, roughly? Again, I want you to just try to visualize this in your mind. Like picture if I took this yellow region and I revolved around I'll highlight it here for you so you can see it. What if I revolved it around this right here? Here's the real question. Would the resulting shape genuinely be a solid, or would it be like a bowl or have a hole? It would have a hole. It'd be a bowl with a hole, yeah, for sure. So let's look and see what that looks like when you revolve it. This one is probably going to get cut off because this distance is really large. Yeah, so kind of get, ooh, this is going to be really weird looking. It's getting cut off just because the program doesn't go as far as it should. But you see how it has a big old hole in the middle? I could do this. I could, just so you can see the genuine shape, I could move this up to like -2. Maybe, yeah, roughly -1. Check this out. Do you see how that's genuinely a bowl with a hole? And again, do you see how the representative elements are washers, not discs? Last time we did discs, these are washers. It's like it's got a hole in the middle. One more. If I made my axis of rotation instead of negative, what if I made it, say, positive 2.8? Something like that. Would that look any different? There it is, right? It would still be sort of a bowl with a hole, but the linear part would be on the outside and the curved part on the inside. It's good. So let's see what that looks like. And we do this so we can actually see the shape a little bit better. It's a cone, but the inside is rounded like Zach described. And it did get a little bit cut off there at the top. So, can I boil this down to you to the big takeaway? Because I guarantee in a room of this size, with you guys in here, there's at least one person saying, oh, so I have to be able to visualize that? My brain's not a computer, how am I supposed to visualize that? The answer is you don't have to perfectly visualize that. You basically need to answer one question. Will the resulting solid truly be a solid solid, or will it be a bowl/hole situation? And if it's going to truly be a solid solid, you'd use discs like we did last time. And if it's going to be a bowl/hole situation, you're using washers like you're about to see. That makes sense? I don't need you to be a perfect artist. I don't need you to sketch things out with perfect precision. I just need you basically to say, is it going to be solid or is it going to be a bowl/hole? If you can answer that question, you'll be in good shape. Okay? So, how do we do this? Let's find out. There we go. And again, just to make it clear, I'll fill in a couple of blanks here. If you're trying to find volume of a solid like this, we'll use what's called the washer method. Hopefully what you just saw there, that makes sense because we're using washers to accumulate the volume. A reminder from last time, the representative rectangle should always have what relationship to the axis of rotation? Perpendicular, that's right. And that's going to be true for us for all of these. And then, what about the actual nuts and bolts, no pun intended, of how we do this? I would describe it like this if I want to just use like really informal language. I would say that the washer method is essentially a disk method minus a disk method. Can you see how if you had a big disk and you subtracted out the middle disk, wouldn't you end up with a washer? That's all this really is. See if you can see that being illustrated right here. Do you see how this blue box is essentially the larger disk method? And this red box is the smaller one. It's basically disk minus disk. That's really all it is. So as far as what these letters stand for, I would say that the capital R of X is the big radius. It's the one that reaches all the way to the outer edge of this solid. The small x would be the small radius that reaches to the inner surface of the solid. And I do have a good way of approaching this to avoid like silly mistakes. Go ahead.
So like with the in the first example with that, or the square root function, would that have been the bigger radius? So that would have been.
Depends on where your axis of rotation
So
is.
when it was below the axis of rotation.
Yeah, then
below the x-axis.
Yep, then the square root would represent the bigger radius. Yep. But then, of course, what's tough about that is if you, hopefully you can still see this, I think you can. If you move the axis of rotation up to 3 or 4, like I did in the second part, now it's the line that's the one that's the bigger radius. Yep. Okay, and then, of course, r of y and r of y are the exact same thing. They're just in terms of y instead of x. That's all it is. Okay, so I am going to show you our first example. And hopefully this first example looks really familiar. It's on the next page. Do you see what I picked? What I picked? This is exactly what we just visualized, right? Okay. So kind of want to work through this with you and just get some feedback. So please don't be shy about saying what you're thinking, especially if what you're thinking is not making sense with what I'm doing. Let's talk. So can I help you avoid the ghastly, fatal math error here? Like the fatal math error being you can do all the work you want, but you're not going to get any credit for it because you've made this big error. So here's how you do this. Step 1, you read it and visualize. So it says for part A, we're going to take this region, we're going to revolve it around the x-axis. So in your mind, see if you can take that region R and just sort of in your own rough amateur, I don't really know exactly what it looks like kind of way, but just do your best and answer this question. If I did this revolution around the x-axis, would the resulting solid genuinely be a solid, or would it be a bowl/hole situation? It's a bowl. Yeah, bowl/hole. So if your answer to that question is, well, it's either going to be a bowl or have a hole, one of those two, then you always use washers. And here's what I would advise you to do. Once you recognize you're going to use washers, write this down immediately. Volume equals pi integral big parentheses squared minus little parentheses squared. You see how this goes perfectly with those formulas of disk minus disk? And we don't know what all the details are yet, but we will in a second. The next thing I've got to decide, if you do it this way, you're doing washers. So that's great. If you don't do it this way, you might accidentally do the wrong disk and not even have a washer. And that's a scenario where we say they don't know what they're doing. They get no credit. But if you write this down, you clearly know what you're doing, at least at the start. Should this be a dx representative washer or a dy representative washer? Why? Or why? Yeah, and the relationship between the axis of rotation and the representative washer is that they have to be perpendicular. Yes. So my representative element could look like this, right there, let's say, which is a dx wide representative washer. The next thing I fill in is the limits of integration. And to understand this, I've got to understand what's going on. I'm just accumulating all of these rectangles. Aren't I accumulating from left to right? So if I accumulate from left to right, where would I start accumulating? At x equals 0. Where would I stop? At x equals 4. I'm accumulating from the left side to the right side, so that's from x equals 0, which is right here, to x equals 4, which is right there. Got my limits of integration. Okay, lastly, I've got to get my big radius and my small radius. Would you guys be okay with this red line representing the big radius? Or I should say these red lines. Doesn't the big radius change depending on where you are? But aren't all these red lines representative of that? So you can't just say that the distance from the axis of rotation to that outer surface, you can't just say that it's 7 or 2 or 3 or something like that. It varies, doesn't it? What is telling that big radius how long to be? Yes, the square root function, right? So what I would do is I would say, well, the big radius is square root of x. Then, I hope you would agree that this orange set of line segments, wouldn't this represent the inner radius? And of course, that inner radius is short or long, depending on where you are on the picture. What is telling the orange distance how long to be? The line. So this distance, this vertical distance, or this y distance is x over 2. At this point, we're done. Because did you notice in the instructions it said, write but do not evaluate an integral expression? I've done it. I'm good. Questions? If you're thinking there's a little more to this, you're right. Remember how I moved the axis of rotation on our little demo? We're going to move the axis of rotation a little bit here. So check this out. So for letter B, it says, what would happen to the volume if instead of rotating around the x-axis, we rotated around the line y equals 3? That, of course, is up here. So I'm hearing you talk. I think you're on the right track. If we did this revolution, if you can picture this solid perfectly, that's awesome. But if you look at it and say, man, I'm not so sure exactly what this would look like, if you can just answer this question, you're good. Would the resulting solid truly be solid, or will it be a bowl/hole situation?
Lampshade.
Say again? It's a lampshade, and lampshades all have, as far as I know, most of them have a hole in them, right? This one has a clear hole. Do you see how this empty area, wouldn't that get rotated too? Creating a hole. And anytime you have a bowl/hole situation, what do you have to use? And as soon as you identify the washer method, you do this. Volume equals pi integral big parentheses squared, which stands for big radius, minus little parentheses squared, which stands for little radius. Next thought. My representative washer will be how thick? It is going to be dx, because what's the relationship between the axis of rotation and the representative washer? I know you've said it before. I want you to say it again so that you won't forget when it comes time. It's perpendicular. Saying things makes it more permanent, right? So I want you to say it. Okay, so if I'm going to accumulate all these lovely washer, rectangle-y things, where would I start accumulating them? At x equals 0, right? I start accumulating right here. I work my way across. So x equals 0, where would I stop?
4.
X equals 4. Now this is going to be that moment. You might think, hey, A was pretty easy for me, so B must be easy as well. Make sure you get this and get this correctly. Would you guys agree, I hope you would, that from here to here, doesn't this represent the big radius now? Sometimes people get a little weirded out because this is different than A. So all those red lines would represent the bigger radius. Does anybody have any idea how you could represent that bigger radius? It's going to involve x over 2, but let me point this out. Isn't this green distance? Aren't those all x over 2s? Right? So you're on the right track. Let me do this. If I drew this in, would you guys agree that the distance from here to here is always 3? Because that line is parallel to the x-axis. So if that distance is 3, and I want the red distance, wouldn't I need to do 3 minus green to get red? 3 minus green? Are you processing? Is this okay? Okay, so 3 minus green. Well, what's green? That's a y value, right?
X over 2.
It's x over 2. There you go. So 3 minus x over 2, that would be my big radius. And then the small radius would be this purple distance from here to there, so on and so forth. So then similarly, if that's always 3 and I want purple, what would I do?
3 minus root.
3 minus blue,
Root x.
which is root x. That's right. So I'm going to go 3 minus root x. And this actually sets up kind of a nice system for you that'll always work. We call this a displaced axis of rotation because it's moved. It used to be on the x-axis and somebody picked it up and moved it and put it up there at y equals 3. Anytime you have a displaced axis of rotation, the radii should be 3 minus the appropriate expression and 3 minus the appropriate expression. And frankly, it doesn't matter which one is above or below. Do you know why it doesn't matter whether 3 is higher than the function or 3 is below the function? Why wouldn't it matter? Well, let me ask you a question. What's 3 minus 7? What's 7 minus 3?
4.
So it seems like they should be different, but I'm telling you they aren't because you're about to square the result, right? So whether you did x over 2 minus 3 or 3 minus x over 2, it really doesn't matter because whether you get a positive or negative, you're going to get the same number squared. It's going to get you the same result. So this will always get you to a good place. Okay, well, we're going to do C some other day. We'll pick this up maybe next week. We'll get it all wrapped up, okay? So let's clear things off. You got fort building material back there. Let's get that going, okay? No calculator.